but I will talk to you about de-anonymizing cryptocurrencies, which is a topic that I have spent a lot of time and energy researching. So before I talk about de-anonymizing cryptocurrencies, I want to mention that I find anonymity for cryptocurrencies really important. So this is not me trying to attack things and break things, but trying to explore anonymity and understand where it breaks in practice so that we can build more anonymous systems. So I used to try to give a talk about just anonymity in general, but I always ran out of time. So now I'm trying to focus a bit more. So again, I think anonymous payments are extremely important if all we have is the level of transparency that we have in existing cryptocurrencies. Then, as we'll see in the rest of the talk, we rarely, if ever, can get meaningful notions of anonymity. And this gives rise to some really dangerous scenarios, right? So people can sort of spy on you and see on where you send your money. People can figure out who is the wealthiest person in their network and target them for potential attacks. And basically, even at an economic level, there's an issue of fungibility, right? There's just a problem in a currency if one unit of that currency is not worth the same as another unit. So again, the focus of my talk is definitely on de-anonymizing cryptocurrencies, but I have worked on positive solutions, trying to design more anonymous solutions, and lots of other people have as well. So if this is something you're interested in, there's lots of resources on this slide. And yeah, again, this is an incredibly important line of research. There's really no way in my mind to do one without the other. In terms of de-anonymizing things though, again, I think the way we can design more effective anonymity solutions is by understanding where existing ones fail. And at the same time, I would personally argue that having completely anonymous payments also gives rise to some definite risks. And of course, we might accept these risks, but we have to acknowledge that they exist. So, you know, I've just put on this slide some of the kind of most famous, I guess, risks associated with Bitcoin, which is not anonymous, but can be perceived that way, or certainly was at some point. And the question that I really want to ask is, what level of anonymity do cryptocurrencies really provide in their current form? So this is a line of research that I got interested in a long time ago during my PhD. This was really in the early days of Bitcoin. And this was around 2012, 2013, and we can see many others were interested in this as well. So briefly, I'm going to talk about sort of my own work in this area, very briefly, by the way. I don't want to sort of give a history lesson here, but just to lay the ground for kind of how a lot of these de-anonymization attacks work, not just my own. So if you think about how do we find out information in the Bitcoin transaction ledger, then you can think, well, there's a number of things we have to figure out, right? So the first issue is, you know, we just kind of have this tangled web of all of these different Bitcoin addresses or Bitcoin pseudonyms. I'll use those terms interchangeably. And, you know, one user, one service might operate thousands, hundreds of thousands, even millions of these different addresses. So just because we see things happening at the level of addresses doesn't really mean that it doesn't really assign any meaning to how users are actually spending their money. So the way this works is we often develop heuristics to form clusters of addresses that represent distinct entities. So for example, we could have a cluster representing an exchange, another cluster representing a dark market potentially, and then we can sort of gain meaning by watching how money moves between these clusters. So again, the work here is to develop these heuristics that essentially say that these addresses all have the same owner. So, okay, we can see now money sort of moving between clusters, but we still don't necessarily know who's who. And so the approach that is often taken here is essentially a manual one, although of course there are ways to automate this somewhat. And this is essentially to collect ground truth data by performing our own transactions in the network. So with an exchange, for example, opening up an account, depositing money into that account, seeing the address that they use, and then taking that money out and seeing the address that they use again. And so by layering these approaches on top of each other, we can actually gain quite a bit of insight into the network, both at the macro level, and it turns out in terms of actually tracking flows of money as they move throughout the network. So this is something that we did successfully, both in this initial paper and, to be honest, in the years since. And again, even in a sort of light academic exercise, we were able to trace over $3 million worth of Bitcoin really directly back to illicit activities that were happening in the network. So yeah, in the years since, I should say this work has really been taken into practice in a way that I certainly didn't predict in 2013. So there are now several companies that do this kind of Bitcoin tracking for profit. This has been used in some relatively high profile cases. And in general, I think, you know, people's perception of Bitcoin has really shifted as well. We're all generally pretty well aware at this point that Bitcoin is not anonymous, that this kind of tracking is possible. Okay, so again, this is kind of a little piece of history. So the question though is, well, what has changed since 2013? So the answer obviously is a lot. Even within the narrower question of, well, what has changed in the cryptocurrency landscape since 2013? The answer is, again, virtually everything. But let me highlight a few changes that are relevant here. So the first thing is that when we did this research, there was literally one cryptocurrency. It was Bitcoin. Maybe by the time the paper was published, Litecoin existed. And now there are thousands of cryptocurrencies. So I actually got this list from CoinMarketCap. I used to keep this up to date going all the way down to the bottom, but they've changed their interface and I got really bored of scrolling and clicking. So I only made it to 2,092 coins, but I think there's probably over 4,000 now. And some of these coins, I should say, are identical to Bitcoin, or they don't exist, many of them. So this sort of tracking analysis applies equally to the ones that just mimic or copy Bitcoin's transaction structure. There are some notable exceptions on this list, though, and these are so-called privacy coins. So probably the three most well-known privacy coins today are seen here on this slide. That's Monero, Dash, and Zcash. And in more recent years, starting in 2017, there have also been a bunch of papers examining the anonymity of these coins. So 2 papers in 2017 looking at Monero, and 2 years ago with my PhD students, George, Haroon, and Mary, we did a piece of research looking at the anonymity in Zcash. So why did we look at Zcash? Well, I think one of the main motivations, actually, honestly, what the main motivation is that Zuko asked me to. But another reason I think is Zcash is really derived from very highly regarded academic research. And in particular, this zero cash paper in which the authors prove cryptographically that Zcash or zero cash achieves anonymity. And so this really begged the question of, well, this really demonstrates a potential gap between theory and practice, right? In theory, you know, I certainly believe the results of this paper are sound, and they have proved that zero cash achieves anonymity. In the years since...
There are actually a couple of errors in the proof in that paper, but they're fixable.
That's true, thank you. So yeah, so in the years since this was published though, of course, there were a lot of decisions that had to be made in turning this academic research into an actual deployed cryptocurrency. And the question is what those decisions meant for anonymity. So very, very briefly, I want to describe how Zcash works. So Zcash has several different types of transactions. So the first type, going left to right here, is T2T transactions. The T here stands for transparent. And T2T transactions are essentially the same as Bitcoin transactions, meaning they reveal the addresses of the senders and recipients and the amount being sent from each sender and the amount being received by each recipient. The main anonymity feature of Zcash is something called the shielded pool. And the other sort of more interesting transactions involve interacting with this. So on the one hand, we have T to Z transactions, which are called shielded transactions. And these, at least I think of as sort of depositing money into the shielded pool. So the sender's address is revealed, the amount being sent is revealed, but the recipient's address is hidden. On the flip side, we have Z to T transactions called de-shielding transactions. Here, the sender's address is hidden, but the recipient's address is visible, and so is the amount that that recipient gets. And then finally, the sort of most anonymous transactions are the ones that happen inside of the shielded pool, and these are called Z to Z transactions. And these essentially hide everything about the transaction. They hide the sender, they hide the recipient, and they hide the amount of money being sent. I'm not going to get into sort of how this is achieved, but it's really great, and I definitely recommend reading the original paper if you're interested. So in terms of the breakdown in usage of these different types of transactions, this is sort of the graph from our original paper when we measured the network in January 2018. So we can see the green transactions here are T2T transactions. So are the blue transactions. The blue transactions are coin generations, which in Zcash's current form are also completely transparent. And so actually, we can see that already only 15% of transactions use the pool at all, right? So these orange ones are the Z to T transactions, the yellow ones are the T to Z, and then this quite small sliver represent these Z to Z transactions. So you might say, you know, a lot has changed in Zcash since January 2018, you know, sapling among other things. And that's true, and it's great to see Zcash evolve, but unfortunately, this pie chart is still not very far from the truth, right? So we can see an updated sort of graph here. I think I did this last week, in which we can see that still the vast majority of Zcash transacted is done in transparent addresses in these T to T transactions. So de-anonymizing these T to T transactions is trivial, basically, because these are just Bitcoin transactions. And so in the paper, we redid this analysis and just confirmed for ourselves that this was still possible. And unsurprisingly, perhaps this landscape was still kind of dominated by exchanges. I think with very few exceptions, most exchanges that will translate money into Zcash only do so using T addresses for now. The other end of the spectrum was these Z to Z transactions. And here, to be honest, we didn't really try very hard. There was no obvious method of de-anonymization. And again, I believe the cryptographic proofs in the original Zerocash paper. But on the other hand, these types of transactions are very, very rarely used. So this leaves open these kind of endpoints into the shielded pool, these T to Z and these Z to T transactions. So if we look at this at just sort of a macro level, this plot shows in a given block the amount of money that is deposited into the shielded pool, meaning the amount of money put in T to Z transactions, and the amount of money that is withdrawn from the shielded pool in terms of these Z to T transactions. And we can see that this is pretty much a mirror image, this graph. And so this suggests that the pool is really largely used as a kind of pass-through mechanism. So people seem to think that if they put money into the pool, they can just sort of take it out again and it'll be clean. It'll be tumbled with all the other money that has ever gone into the pool. And unfortunately, this really just isn't the case. So to see that, we can actually start examining not just the money going in, but actually who are the people making these transactions. So for this, again, the details are all in the paper. I realize I'm going through this quite quickly. There's sort of three categories that we considered. The first category was miners. So it's easy to detect miners. They're the ones getting the majority of newly minted coins. Founders are also easy to identify by looking at coin generation transactions. They're getting this smaller chunk of newly minted coins. And then others are just literally anyone who's not a miner or a founder. So yeah, the other thing about miners and founders is that why are we looking at newly minted coins? Why are we looking at coin generation transactions? Well, the consensus rule in Zcash says that all newly minted coins must immediately go into the shielded pool right away. So you can't get the output of a coin generation and then do a T2T transaction with it. You have to follow it with a T2Z transaction. So if we look at the deposits into the pool and we break them down into these categories, we see pretty much the proportions that we'd expect, right? So this pink line here represents miners, and this sort of blue line represents the founders. And so we can see things broken down, again, roughly in the proportions that we expect. If we try to take the addresses that we identified according to the coin generation transactions, though, and try to look for those exact same addresses as the output of a sort of withdrawal transaction, then we don't actually see much. Okay, so I should say the sort of ideal anonymity that you could get in Zcash is if that orange line representing others were following exactly the black line representing all transactions, right? So the sort of gap in anonymity is essentially the gap between those two lines in the graph. So we can see that some of the miners reused the exact same addresses, but mostly this didn't really happen. There wasn't any obvious reuse. Unfortunately, though, by developing sort of custom heuristics for both founders and miners, we were able to shrink this anonymity set significantly by 65.6%. And in fact, even just by looking at this others category, by linking transactions based on value, we were able to capture an additional 3.5%. So essentially, this means that for 69.1% of the transactions coming out of the shielded pool, we were able to link them to a deposit going into the pool and thus rule them out of any possible anonymity set for anyone else, right? So if you thought when you were withdrawing money out of the pool that you were hiding amongst 100 other participants, this research basically shows that in fact you're hiding among 31 participants rather than 100, right? So this is what it means to sort of shrink the anonymity set in this way. Okay, so this is our research applied to Zcash. Again, around the same time, there was similar research applied to Monero. And so this suggests that even for these privacy-focused coins, it's definitely possible to erode the anonymity that people have, right? We're not saying there's nothing left, but there's certainly a lot less than you might have thought there would be naively, and certainly at the theoretical level. So this is sort of what's happening within coins, right? So one thing that's changed is there's thousands of cryptocurrencies, some of them very focused on privacy. And the answer here is, well, to be honest, at least today, we can usually de-anonymize these two, at least to a certain extent. So another thing that's changed is, well, what happens if we try to move across coins, right? So in this original sort of Bitcoin paper, we had this quite strong assumption, right? And the assumption was no one wants to hold on to Bitcoin, right? This was when you really couldn't do anything with Bitcoin. And so we thought, well, anyone who's sort of stealing Bitcoin or accepting Bitcoin in an illicit way probably just wants to cash out, right? They probably want some form of fiat currency rather than these Bitcoins. And at the time, again, this is 2013, there were some really clear gatekeepers in and out of the system. So if you wanted to get your money out of Bitcoin, you had to go through an exchange. There were not many exchanges at the time. And so we had this hypothesis that if you tracked money to kind of the doorstep of an exchange and you were able to subpoena that exchange, then you could identify that thief or whatever, that criminal actor. So another thing, again, that's changed is this entire landscape, right? So today there are way more exchanges than I can count. Many of them would certainly not respond to any subpoena requests. And but aside from these kind of centralized exchanges, the question is, how else is it possible to cash out? So again, one answer lies in, just create a sort of criminal exchange and try to use that. People have done this, by the way, plenty of people. But I would argue that any centralized exchange still runs the risk of being shut down. Another way, though, that you could try to cash out actually lies in this exact same observation that there are now thousands of currencies today, right? So what if you accepted Bitcoin or Ethereum as the result of some kind of illicit transaction, whether this was stealing money or the sale of drugs or whatever? So rather than just taking that sort of tainted money right to an exchange, what if you tried to transact across these cryptocurrencies? So what if you moved your money into Bitcoin Cash, then you moved your Bitcoin Cash into Litecoin, then you moved your Litecoin into Stellar, and then you moved your Stellar back to Bitcoin, and then you cashed out? Or what if you cashed out from one of those intermediate chains? Right? So this, on the surface, would make things a lot harder, right? We couldn't just sort of do this tracking within a single coin and identify and follow you to the exchange. So it turns out that you can actually transact across these currencies in a decentralized way, right? And this is even more possible now than when I first made these slides. So in particular, there's sort of these very lightweight trading platforms that exist today that make it possible to move different cryptocurrencies without using custodial accounts. And in some cases, without even having to identify yourself to the operator of this exchange, right? So I should say Shapeshift today, since we did this work, has definitely shifted to implementing Know Your Customer policies, to requiring some form of registration. But at the time it didn't, and there are certainly platforms today where you still don't have to. So the idea with, again, the sort of older version of Shapeshift is you say, here's the money I have, and here's the currency I want. So in this case, we're transferring from Bitcoin to Ethereum. You then give the address in ETH where you want to receive the output, and then you send them the money using their Bitcoin address, and they'll sort of do the transaction for you and send the resulting ETH to the address that you've given them. So this is kind of what it looks like in terms of the transaction ledger, right? So we can sort of see in the Bitcoin ledger, if you just focus on kind of the right side of the image, we can see a transaction to a Shapeshift address, assuming we can do this kind of clustering for Shapeshift, which we can. And then on the Ethereum ledger, we can see, again, some transaction from a Shapeshift address to this recipient's Ethereum address, okay? But there's no obvious thing linking these. So this is actually something that some criminals have tried to exploit. Probably the most high-profile case to date is the WannaCry hackers. WannaCry was a form of ransomware that was very big a year or two ago. And so what the WannaCry ransomware operators basically did is they accepted ransom in Bitcoin. They then sort of tried to move money around within Bitcoin, in some cases very directly, and in some cases they tried to be a bit more clever in how they transacted. But eventually it, again, these companies that kind of track Bitcoin for a living noticed that it went to Shapeshift. And the attempt was to Shapeshift into Monero, which is, again, one of these privacy coins. So by finding it and by contacting Shapeshift, this was prevented. But we can kind of see this really cheesy headline, Bitcoin crime evolves in a multi-blockchain world, right? So we can already see this idea that criminals are saying, well, is this something we can exploit? So the question is, we have these transactions, right? So there is this implicit meaning in what's going on. We can see that money is going to Shapeshift on the Bitcoin ledger and from Shapeshift on this other ledger. And so the question is, can we infer these links? Can we sort of cross these different ledgers given these transactions? So the answer is yes. The answer seemingly in this space is always yes, to be honest. So not just by using the blockchain data, but also by using the Shapeshift API, it is definitely possible to link the transaction in the input currency with the transaction in the output currency. So the way we can do this is we can get information from the Shapeshift API, and we can see an example here of what this looks like. So Shapeshift will show you the details of a transaction in terms of the currency in, the currency out, and roughly, the amount of the input currency that was sent. There's also a rough timestamp. And so using that timestamp, we can look for the approximate date, the approximate time of this transaction in the input currencies ledger. So meaning we can look for transactions that roughly match this timestamp. You know, maybe they're a little before, maybe they're a little after, and match this amount. So here we can see we found this one. This is from September. The timestamp is closely aligned with the one that Shapeshift gave, and the amount is exactly the same. Then we can actually reuse the Shapeshift API to actually plug in this transaction details. And actually, we can see a lot more information now. So in particular, we can see the matching address. We can see the withdrawal transaction. We can confirm that the output currency was indeed XMR, which is Monero. And we can actually also see the address in Monero where this money was sent, right? So this is all just by plugging in that address that we found in the input ledger into the Shapeshift API. So we followed these steps. We initiated this research in November 2017, and we ran this scraper of the Shapeshift API for over a year. And we observed a lot of usage. The sort of top 8 cryptocurrencies that were used are on the right here. And on the left, we can see the usage of these different currencies, of these top 8. So we can see that for a while, until these KYC regulations were introduced into Shapeshift, we can see that the total transaction volume on Shapeshift is actually quite closely aligned with the price of Bitcoin. But we can actually see a quite significant drop even before the Bitcoin price drops after KYC was introduced. Again, there's a lot of details in the paper, which we published last year, again, with my PhD students, George Kapos and Harun Yusuf. So here are just a few more potentially interesting findings. In terms of focusing on criminal uses of the platform, we observed many naive attempts to do things. So we looked at one kind of, again, high profile case, which was a fraudulent ICO called Starscape Capital. And we watched them shift their money into Monero. Interestingly, while they shifted a lot of money and while they performed 109 different shifts, they used only 3 Monero addresses in terms of receiving the funds. And so again, kind of making things easier if you then wanted to continue this analysis and try to track their funds within the Monero ledger. We also focused on privacy coins and again saw that a lot of people frankly don't seem to understand how this all works. So we saw this particular pattern that we called a U-turn, in which very similarly to the use of this Zcash shielded pool, people seemed to think that if you put money in, if you immediately took it back out, your money might be cleaned in some way. By the way, I should say, as I say that out loud, there are plenty other reasons why people might transact in this way, right? So people sort of doing high frequency trading of a sort might do these kinds of U-turns. So it's not, necessarily that they didn't understand, but just that maybe they weren't interested in the features of these privacy coins or weren't interested in what they had to offer. So this is essentially another big change since 2013. And I think, again, with the very recent rise in kind of DeFi, decentralized finance, as a phenomenon, there's lots of other potential to do similar types of studies, right? So Shapeshift was kind of one of the first examples we saw of this type of platform. But the way things work today, I would say that trades across cryptocurrencies are arguably more transparent than ever because they're done in this decentralized fashion. So we were certainly able to track money as it moved across Shapeshift, and it'd be really interesting to see how this might work on other platforms. So the final thing I'll mention, the final change that's happened since 2013, is that a lot of transactions are actually moving off-chain, right? Are not appearing on a persistent ledger, but are just happening within the context of a peer-to-peer network. So one example of such a off-chain system is the Lightning Network, and we have done some recent work on this. I won't say anything about it here because my PhD student, George Kapos, will be talking about this on Thursday. So please do join in then if you want to hear more about that research. So just to summarize, again, anonymity is incredibly important. I think we all agree that even if there are risks associated with anonymous payments, having a completely transparent ledger of payments is probably not desirable either, is probably not something that we could really see gaining any kind of mass adoption. It's a really subtle issue, and we've seen that it's really hard to get right. Even if you start with something where the theoretical design is quite sound, the real practical constraints of deploying a system like this and getting adoption and interfacing with existing systems makes it really hard to achieve anonymity. So yeah, this is something that I definitely advocate for exploring from both sides, both trying to construct anonymous solutions and then trying to understand the limitations of existing ones. So with that, yeah, thank you very much for listening, and I'd be happy to take any questions. I can't actually see any questions with my current setup.
Thanks very much, Sarah. Yeah, the mics are open. Everybody, please go ahead and ask your questions.
I see.
Thank you, Sarah. Sorry, go ahead.
Saying, like, I see one in the chat too, that somebody.
Arthur, do you want to go?
Oh, yeah, sure. I would love to. Before, like, cash, right, which is like a deposit withdrawal protocol on Ethereum, would you think it's kind of like similar in terms of privacy to Zcash, like basically just handing it as kind of as a pool where you deposit and withdraw in, or would you model this somehow differently if you were to analyze its privacy? So
sorry, I missed the first part of the question, but I'm going to assume it was about Shapeshift.
Oh, it was about Tornado Cash. Vitalik mentioned earlier Tornado Cash in his Q&A. It's a protocol that allows to deposit and withdraw coins into a ZK shielded pool, similar to Z transactions in Zcash itself.
Okay, right. Well, sorry, I wasn't there for that, so I've missed that discussion. But yeah, I think other ways of interfacing with the Zcash shielded pool can definitely be more successful. I would think that if they came from a transparent source and went to a transparent sort of recipient, then I would think that it would be quite similar to de-anonymizing these T to Z and Z to T transactions in Zcash. But the nice thing about this empirical research is you really don't know until you've kind of gotten your hands on it. So yeah, in theory, I guess I could imagine it looking similar, but in practice, I'd have to sort of see what's there before I could say anything.
Thank you. More work to be done.
Yeah.
I have a question. There are actually two shielded pools in Zcash. There's the Sprout pool and the Sapling pool, because obviously sapling was introduced to improve the efficiency of the protocol. But the only way to move funds from Sprout to sapling is by revealing the amount. That's so that we can sort of have greater confidence in that no balance violations occurred. Have you done any research, or are you aware of any research on de-anonymizing that? Because there's a specification for how to do it, and it's implemented in the zcash client. But I don't think I'm not aware of any detailed analysis of it. That's in ZIPS 308.
That is a great question. I am not personally aware of any research, but it's definitely something I might be interested in taking a look at.
Yeah, so that specification does split up transactions into pieces of fixed denominations and tries to increase the anonymity set by sending them only every, I think it's 500 blocks. But I don't know how effective that actually is.
I have a question, Sarah. This always seems like a cat and mouse kind of thing. Is there hope for us to get proper privacy with large anonymity sets in the future?
I definitely think so. I mean, I've seen discussions about essentially turning Zcash into just the shielded pool. And of course, there are difficulties associated with this. So, you know, how many exchanges would want to transact with Zcash at that point? You know, how many would adopt, both on a technical level and on a kind of, you know, being concerned about the potential regulatory issues level. So yeah, I don't know. I'm not part of those discussions, I should say. So I'm probably not going to say much more about it than that, because I don't really feel qualified to answer. But I definitely think, you know, we're seeing a lot of progress. I mean, I should also mention the papers de-anonymizing Monero were relying on largely outdated features of Monero that have since changed. And so as Monero evolves, you know, you would expect those attacks to become less and less relevant as well. So, you know, this doesn't tell the complete story of these cryptocurrencies, you know, as they exist even today, and definitely not as they will exist in the future.
I think actually that there hasn't been enough work done yet on active attacks. A lot of the papers are on just passive attacks.
Well, that is due to ethical considerations and concerns. We certainly don't want to be actively attacking anyone's privacy.
We had a question submitted in the Q&A box from Remco, who said his microphone is not working. But wouldn't Monero be more anonymous compared to Zcash, as it allows for non-shielded transactions? And then the same shapeship scrapping is still possible, though the criminal use would be smaller. Do you agree with that for the two?
Okay, thanks, Sarah. So yeah, the Monero one first. I mean, look, I don't want to step into this debate. I have personally done this study looking at anonymity in Zcash. I have done no studies looking at anonymity in Monero. And for myself, until I've done them side by side, I don't really feel qualified to compare their level of anonymity. That being said, you know, I do think there's something to the fact that today, anonymity in Monero is essentially turned on by default, right? So in the past, it was possible to make a transaction that was not anonymous by using a sort of zero mix-in. Today it's not, though, and so that means that every single person sending money in Monero has to be using its anonymity feature. And I think this does stand in contrast to Zcash, where the shielded pool is essentially an optional feature. So again, I've seen a lot of work in this direction. I think I've seen the development of wallets or discussion of the development of wallets that are essentially only interacting with the shielded pool. So the default is not T to T. It's not even that Z to Z or any of this is an option. It's that this is how this wallet transacts. So, you know, I do sort of hope that we will see the dial move a bit there, that we will see more just sort of default is the shielded pool. And then what you would have to opt in for is working outside the shielded pool. Today, though, the default is still T to T. And so we are still seeing, again, most things being transacted there.
And an example of that is the Nighthawk wallet, which was recently released for Android.
Thank you.
I think an iOS version is on the way. It's worth pointing out that the traceability set, so the set of possible outputs that can go to an input in Monero and Zcash are very different. So in Monero, you basically have a ring size of 11 by default. So there are 11 possibilities for that. Whereas for a shielded input in Zcash, it could in principle be any of the past shielded outputs. Obviously, an attacker might control some of those and be able to eliminate them. But it is, yeah, that's worth considering besides the sort of the number of users.
And then for the other question, I haven't checked, admittedly, in a while what Shapeshift's current API is. As far as I know, they still make some data available. I think that, I think I saw Haroon on the call. He can tell me if he has more up-to-date information. Pretty shortly after our paper was published, they did make the API more restrictive. In particular, we were able to scrape a list of the 50 most recent transactions every single time we queried. And so we ran that, I think, every 3 seconds, 5 seconds, something like that. And so we were able to get pretty high coverage of the transactions, at least the ones that they were kind of making available on this API. Last time I checked, you could only get the most recent transaction on Shapeshift using this particular call. I don't know if they've changed that since, but yeah, it would certainly make it a little bit harder to scrape. And as for criminal usage of the platform, you never know, honestly. I'm not sure if I would expect it to be any smaller than it was. I mean, criminals in the cryptocurrency space seem to have an inflated idea of what they can get away with and a sort of underdeveloped idea of what information exactly they are revealing. So you never know.
And there is actually quite a detailed report on the potential criminal usage of Zcash, which concludes that there isn't actually very much criminal usage of it. That's the RAND report, which is linked from electriccoin.co.
What exactly is the incentive behind the folks operating Shapeshift to make their API public or not public?
I don't know, to be honest. I think when Shapeshift started, they were definitely concerned about regulatory scrutiny. And this is, by the way, a complete theory. Sorry? Okay, so yeah, one theory is that this is a way to be transparent and to show that they're not trying to hide anything. You know, they're not trying to enable criminality in any way. But again, I don't know. I don't work there.